We'll now talk about the 7 assumptions for multiple linear regression, and then we'll move on to doing some examples. We've already talked about the levels of measurement for each of the independent variables. It needs to be continuous or dichotomous, and we're using any number of independent variables to predict a single continuous dependent variable. There are various guidelines for the sample size, and you need to read between the lines a bit as to what the general suggestions are. One method is to use a minimum of 5 cases per predictor. So if you've got 4 predictors, you'd need 20 cases and multiply by 5. But ideally 20 to 1. So if you've got 5 predictors, you'd want at least 100 cases. Tabachnik and Fidel offer another guideline, such as starting with 50 plus 8 times the number of predictors, or starting with 104 plus the number of predictors. But really, roughly over about 100 for most models is a desirable sample size to aim for. Now the next 2 assumptions can be tested by looking at scatter plots, bivariate scatter plots between each of the variables, and in that way you can assess linearity. Are the bivariate relationships linear, or at least are they not non-linear? Watch out for curvilinear or very skewed sorts of plots. And homoscedasticity, is there even spread around the line of best fit, or does it fan out? Multicollinearity refers to the situation where the predictors are overly correlated with each other. This can be most easily assessed just by looking at the correlation matrix and checking whether there are any predictors that are correlated above about 0.7, which means that they share 50% or more of their variance, and if so, maybe consider dropping one or merging the predictors into a single factor. You can also get the VIF or the tolerance, or both, which are diagnostic statistics to estimate the multicollinearity. Now guidelines vary for interpreting the VIF, but it should be low, and it should be less than 10, and preferably even less than 3. And the tolerance is just the reciprocal. It's 1 minus VIF, so it should be greater than 0.1 and preferably greater than 0.3. Multivariate outliers are assessed by calculating Mahalanobis's distance for each case and comparing that maximum value against the critical value, and we'll see how to do that in the exercises and what to do about it. And it would follow those instructions. And finally, that the residuals should be normally distributed. So if we have a scatter plot like this, a line of best fit, then the residuals are that distance. It's a positive distance, and in this case a negative distance. So each case has a residual which represents its vertical distance from the line of best fit, and if you then gather that data and plot the values, that they should follow a roughly normal distribution, with a few points that are very close to the line, many points that are sort of a medium distance from the line, and a few like these ones that are far from the line of best fit.